Hello guys and welcome. I hope that you are well. My name is I play 4K, aka I play 8K, aka I play 16K or UHD. During this video, I'm going to show you my gaming PC from 2019/2022 will be i9 9900K overclock at 5.3 GHz of external frequency per each core with only 6 cores enabled in the BIOS, no hyper-threading technology, and I'm going to show you the tests in Corona version 1.3 benchmark, Cinebench R15, R20, R23, AIDA64, CPU Z, and WinRAR and 7-zip. So pretty much it's going to be a benchmarks that you're not supposed to run on a gaming PC, especially on a computer or a CPU that you disabling the cores, particularly to have the higher frequency in PC gaming needs, and having lag throughout the multi-threading by doing so. But it's going to be a multi-threading benchmarks for those who curious how fast this computer will be with only 6 cores, Intel 9000 series running 5.3 GHz, stable as rock. Okay, it's never blue screens, keep that in mind. And the Corona version 1.3 benchmark very well going to test your overclock at any conditions, keep that in mind. So as you can see, we're going to start with the Corona 1.3 benchmark. By the way, there is a beautiful SDK render API, Corona SDK, guys, that I'm about to study. I find out about it yesterday when I watched the video about the founder of the Doom and the Wolf such a games, and Heretic. It's old school FPS games, PC games in the 1990s, and he advised to use the Corona SDK, and I'm going to use in the future Corona SDK because you can develop Android mobile games and apps as well as iOS mobile games and apps throughout the Corona SDK. Alright, so I'm coming you guys in real time and everything will be explained. This video is not going to be as fast as possible, but throughout this video we're going to underline pretty much how fast Intel Core i9 9900K gaming scenario tune at 5.3 GHz in workstation benchmarks. Okay, so as you can see, let me zoom in. I'm going to use a zoom tool. Okay, it scored 2,613,760 points. Okay, and this type of benchmark is using the AVX2 instruction frequency on the Core i9 9900K, and it's going to be clocked at 52 multiplier and outputting 5.2 GHz per core or 5200 MHz per core, but only 6 cores, 6 threads. But very amazing, and keep in mind that it's going to thermal throttle the CPU because everything above 5 GHz on the Core i9 9900K is unstable, or you gotta use the very high voltage and it's gonna bring the temperature that even the Corsair H150i water cooler AAO system with a 360mm radiator and 3 120mm fans cannot cool it down. So keep that in mind. It's very hot. However, I'm using today the Corsair thermal compound paste, not liquid metal thermal compound paste, but even with 3 Celsius down, maximum will be 5. I'm pretty sure we're still going to thermal throttle, and at this scenarios it's thermal throttling to 48 multiplier. So it's overriding the 52 multiplier to 48. It happens only when the temperature is getting too hot on the Intel 9000 series CPUs, and pretty much it's not healthy 5.2 GHz. So my advice to you, if you're running as workstation, do not ever overclock i9 9900K. It's just ready for it without any overclock, or maximum set your AVX2 instruction to 51 multiplier and frequency, external frequency to 51 multiplier to synchronize it for the best possible scenarios, but still use the 8 physical cores and the hyper-threading technology for the best result while doing the as workstation, but while playing the games, go ahead and disable 2 physical cores just like I did. Use the 53 multiplier and very crazy voltage, but the temperature will be nice in the games. It will never go above 75 Celsius ever. But as workstation, when every single CPU core is utilized at 100%, this is what you're gonna get. You're gonna thermal throttle, or you're gonna see the blue screen if it's not going to be enough of voltage. But if you're gonna deliver enough of voltage, it's going to go very hot, and pretty much it's going to bring down the frequencies through the thermal throttle process. Okay, hopefully guys this makes sense. So this is the first test. Let me close that, and the information is right here. As you can see, passes total 16, ray samples 51.5. there is instances and beautiful info here. So I also did let me go ahead and jump into the AIDA. I did the AIDA64 GPU benchmark. Okay, and I compared Titan RTX video card, a single video card right now installed in this system, which is a great video card when we are talking Octane rendering in Blender, an application for 3D artists or 3D architects. It's beautiful application, guys, when you're working with 3D. And so Titan RTX video card, or it's great video card for PC gaming as well. It's going to act as RTX 2080 Ti, a little bit faster by 10% than RTX 2080 Ti. But if you're purchasing this as gaming video card, make sure the price is right. You're purchasing most likely used, and make sure that price is around the RTX 2080 Ti video card as used. This is going to be fair price. Okay, this is based on my experience as owner of both RTX 2080 Ti video cards and Titan RTX video cards. Titan RTX video card is also great video card when we're talking Bitcoin mining. So in 2021, throughout the whole year, throughout my experience for YouTube, a single Titan RTX video card by stock produced 53 megahash per second, 53-55. So it was 53 megahash per second on a stock thermal compound paste, still using NVIDIA dual fan design air cooler. But when I replaced the liquid metal thermal compound paste, it was like, you know, the temperature went down, and the megahash went like 55 megahash on stock frequencies. And then I overclock it and tune it down a little bit through the UHD King tune. I achieved 65 megahash per second constantly 24/7, and the temperature never reached above 70 Celsius. This is very crucial. Okay, it's going to be my tune. It's going to be available over the UHDking.com when I'm going to share it with you guys. It's going to be a beautiful video tutorial. If you're into the Bitcoin mining, you want to check it out. So anyways, I also did the AIDA64 cache and memory benchmark. This is for the system RAM. So memory, which is the system RAM, then it's on CPU level 1 cache and CPU frequency, level 2 cache and level 3 cache, and the whole cache and how fast it is, how much bandwidth it can produce. Okay, so latency delay in NS. NS stands for the nanoseconds. So pretty much what will be unchanged, latency delay will be unchanged no matter, even if I'm going to add 2 more cores and overclock it to 5.3 GHz, latency delay will be the same, as well as for the system RAM, which is the memory or level 1, level 2, level 3 cache. However, if I'm going to add 2 more cores and hybrid threading technology, my level 1 cache, level 2 cache, level 3 cache, read-write copy bandwidth will be increasing dramatically, but not so dramatically when we are talking about this 6-core overclock to 5.3 GHz, because it's going to increase only by 200 gigabytes per second. 200 gigabytes per second. Okay, so stock i9-9900K is running 21 gigabytes per second, 2100 gigabytes per second. Okay, same thing will be applied to level 1, level 2, level 3 cache. It will be increased the values if I'm going to add more cores. Keep that in mind. Okay, so 6-core Core i9-99, or this is how the best scenario for 6-core 9000 series Intel CPU, the best chosen, you know, diamond rock chip, and everything what I provided to you. So 1650 megahertz times 2 because DDR4, which is 3300 megahertz, CL11 1T command, and core cache frequency is running at 48 multiplier, which is the 4800 megahertz or 4.8 gigahertz. Keep that in mind. Okay, and let me real quick go ahead and show you CPU Z, and we're going to jump back into the AIDA64. So 6 core 6 threads, just like I told you, 53 multiplier, so pretty much constantly 5300 megahertz when we are needing that frequency decided by the Intel driver and Windows operating system. Today I'm using Windows 10 professional operating system on this particular system, but keep in mind I'm reinstalling the operating system constantly. Okay, because I'm playing and benchmarking and testing the hardware constantly. So this is what's up, guys, right here. So Titan RTX was running PCI Express version 3.0 and it was pushing pretty much the same bandwidth as 16 times, but I was running 8 times. Not sure why Maximus 11 here motherboard does it, but it does it. It's supposed to be 16 times. It's supporting up to 16 times, and I'm not using any M.2 drives, SSD drives. I'm not using any extensions, any extensions as video cards. Any other PCI Express slots are empty. Not sure why Maximus 10 and Maximum 11 motherboards are doing that with the Core i9 9900K CPUs on them, guys. Alright, so 3300 megahertz CL11 1T command. Okay, but CL11 very aggressive timing, 1T command, dual channel, which means 128-bit. Okay, I'm using the 4 sticks, 8 gigabytes, and I'm using very expensive and very rarest Corsair DDR4 memory, which is the 5000 megahertz CL18, and it's going to be the Micron chips. It's not going to be the Samsung chips. Keep that in mind. And the problem is Samsung chips easy likes to go high frequency, but Micron chips doesn't like the high frequencies. Micron chips like the low latency pretty much settings, and this is how I'm utilized this and benefited a lot throughout the CL11, which is unheard of aggressive timing for the DDR4 3300 megahertz CL11. This is where is the key, guys, to get the lowest latency delay between the CPU and system RAM and get faster FPS and faster performance. 1T command. Okay, so Titan RTX video card was running 7000 megahertz on a GDR6 by stock by NVIDIA, but just because GDR6 it's times 2, 14,000 megahertz output, and I overclocked it in MSI Afterburner, as you can see, additional by 1000 megahertz, so pretty much times 2, 2000 megahertz, so from 14,000 megahertz to 16,000 megahertz, boosting with additional 100 megahertz on a GPU overclock, which will be above 2000 megahertz when it's running and not thermal throttling, but running below 60 Celsius only. Keep that in mind, otherwise it's going to start thermal throttling after 62 Celsius or when it's going to reach 62 Celsius. Hopefully, guys, this makes sense. And this is the benchmark. As you can see, single thread performance will be 638, almost 639 points or 640 points. And this is what we are talking, where we're talking the gaming performance. We're looking at this value, but when we're talking of workstation, we're looking at this value. For the workstation, I have two Xeon C5 2699 V3 CPUs running in dual socket motherboard, two of those CPUs, and it's just boosting up over here 12,000, above 12,000 points as workstation. But single thread performance is getting like 250, 236, 256, but this is like 3 times almost over it, and this is a great as gaming station, as gaming system, because games likes less cores but as highest frequencies as possible, and if those cores are not bottlenecking your Gucci, okay, means that the overall CPU usage is not getting above 90%, then you're not bottlenecking in terms of the cores, and then higher frequency will boost you in terms of the FPS in PC games. So if you're going to add more cores, you're not going to benefit, guys. Hopefully this makes sense. Okay, let me real quick show you how it's compared to the today's CPUs. So this is the Ryzen 3950X, still great old school CPU, and we are outperforming almost by over 100 points. This is unbelievable. 7980XE Extreme Edition, we're outperforming by 120 points. 10900K, we're outperforming by 40 points, unbelievable. And 10700, look at this, outperforming by 60 points, above 60 points. 3700 2x, outperforming by 120 points. Same CPU, 9900K, guys. Pretty much, look at this. On multi-thread performance as workstation is not even double as our performance, but that CPU at stock running 16 logical processors, just like mine in stock. If I'm not going to disable the 2 physical cores in the BIOS and hyper-threading technology, it's going to be, guys, 16 logical processors, and I'm only today running 6 logical processors, and it's not even double because our frequency is 5.3 GHz versus 3.6 GHz on that CPU. Hopefully, guys, this makes sense throughout the multi-thread performance benchmark. And as you can see, 6 core scored 5.7 times, which is great in real-time performance as in real-time benchmark. 6950X for those who's curious. Let me show you some more CPUs for those who's curious, and we're going to move on to AIDA64 real quick. We don't have the whole day, but everything will be explained for those people who's building the Core i9-9900K and looking as a system. And guys, throughout my videos, everything will be explained, and you're gonna decide if you need it or not. Just watch my videos. Check it out, 8700X. We outperforming so bad by 140 points almost. Wow, single thread performance, and we're as equal as, look at this, 8700K, but that CPU is running 12 logical processors and I'm only running 6 logical processor. Performance almost the same, and that CPU is 1 generation older than this CPU that I'm running right now. Unbelievable, guys. And the 7700K old school CPU right here, check it out. Still beautiful performance for that old school CPU, but we are outperforming by 180 points. Not so much though, but 180 points. 6700K, check it out. 4790K, also legendary CPU right here. 2600K, check it out. Yeah, this is how fast, and this is pretty much, I call it as a gaming mode, guys, and I believe that AMD and Intel will adapt this technology, and also the Apple will adopt this technology in the future on their devices or on their chips built in. So it's going to disable some cores while enable the higher frequency and higher voltage, and less wattage and less heat will be used, and while doing that type of operation, while playing games at a higher FPS, as well as consuming less energy. This is how I see it, guys, as an engineer and as a software developer. Hopefully, guys, this makes sense. I'm trying to explain throughout my videos, but today you just learned that. E8500, look at this very old school Dell CPU that I had, and I pretty much reviewed that CPU in Fatality Motherboard over this channel, UHDking.com, long time ago. Go ahead and check it out. Okay, anyways, and yeah, this is the AIDA64, some very valuable benchmarks, but let's go ahead and go through all the benchmarks. So memory read, you can see my CPU will be right here. So 48,768 megabytes. Rate will be 50,213 megabytes, which is 50 gigabytes. Copy will be 47,386 megabytes, almost 50,000 megabytes as well, which is 50 gigabytes. Latency will be 42.9 nanoseconds. NS stands for the nanoseconds. The lower value, the better. Just like MS stands for milliseconds. The lower value is better. This is how we want to do it, because it's a latency delay between the CPU and some other components in our system, CPU and system RAM. This is the memory latency. As you can see, this is the stock Core i9-9900K, the same CPU that I benched, the same. This is the same CPU. Stock is 60 nanoseconds, and I'm almost 20 nanoseconds faster than that with a lower latency delay by 20 nanoseconds. This is unbelievable. Almost 50% of the performance boost in communication between the CPU, each CPU core, to the system RAM. Okay, even if system RAM maximum capable 50 gigabytes per second, but it's still great. It's 6 times slower than our, not 6 times, but 4 times slower than our level 3rd cache on our each core on our CPU. But still, the faster the better, means the more bandwidth we can push to the CPU to compute and to perform faster computing pretty much abilities on that CPU, while it's capable to perform and compute more data. So the more data we're gonna push it through the system RAM into the CPU, the better. That means the higher frequency in DDR4 will be the better, guys. Hopefully this makes sense. As you can see, I'm trying to explain for everybody and for the beginners as well. So CPU Queen, check it out, nice. As again, all those CPUs benchmarks will be multi-threaded benchmarks, most all of them, except the CPU Queen PhotoWorks. Those kind of will be mostly like based on a frequency and a CPU cores, but the rest of them will be based on the CPU cores. That's why I'm not going to score very high, but as again, because I'm only using 6 core 6 threads, which is 6 logical processors, but 6 physical processors, 6 physical cores is used in the BIOS. Hopefully guys this makes sense. So this is going to be only the benchmark under the AIDA64 when frequency actually is almost the king. It's going to be frequency plus CPU cores are the king in this benchmark. Okay, everything else will be based on the cores, and the memory read, write, and copy and latency will be based on the frequency of the CPU frequency on each core and the memory system RAM frequency. Hopefully guys this makes sense. ZLib, check it out, 442 megabytes per second. Okay, the other is CPU benchmark AES, the other one SHA3, which is 2068 megabytes per second, great value for 6 core, for raw 6 core but very high frequency. Julia CPU benchmark 46,000 for those who's curious. Mandel, this is for those guys who's doing a lot of decryption encryption stuff, will be good benchmarks to have and to understand as well if you're building a system that's doing just that. So 23,442 points, that's great. Score almost as my 8 core, but it's 2 CPUs, each only 4 cores enabled in the BIOS, total 8 cores output. Xeon's E5 2699 V3, clock at 300 MHz, 3.3 GHz constantly. Guys, that's why I only enable 4 cores in the BIOS per each CPU on a dual socket CPU motherboard, C612, that Chinese one that I reviewed over the UHDking.com YouTube channel. Go ahead and check it out. The full review of dual Xeon E5 2699 V3 processors will be available over the UHDking.com website. Go ahead and check it out, guys. It's a great valuable information if you into 3D rendering, if you into build a great workstation that utilize all the CPU cores at 100%. This is the benchmark for you to do, and pretty much to test your system. The AIDA64 gonna test your system a lot, then Corona and Cinebench. Any single benchmark that I'm gonna show during this video is going to be the benchmarks for you to do for your workstation. But as again, today we are applying the gaming system that is not as workstation, has less cores but very high frequencies, just to find out how it performs for the PC enthusiasts. So go ahead and smash that like button if you're PC enthusiast, because guys, I spend a lot of time, money, energy, and show me your love and respect me, and more videos will be available for you to watch. So FP32 ray traced, this is a heavy CPU benchmark. We're 9,000 kilorays per second. Unbelievable, guys. Almost as fast as 16 cores, but first generation Intel Xeon's E5 2670 with a hyper threading, which means like 32 logical processors. We're almost as fast as those 32 logical processors, but from 2012. Okay, 4,842 kilorays per second on the floating point 64 ray trace CPU benchmark. Unbelievable value. Okay, that's it, guys. Let me show you the motherboard CPU ID. That's it for the AIDA64 benchmark, I mean, and the value that this CPU supported for those PC enthusiasts. For those people who's curious, go ahead and smash that pause button, and if it's too fast for you, and you're gonna see what kind of instructions supported by this CPU if you're building some specific system and you're watching this video to get some data, some information. This is, as again, a video with a multi-value and multi-angled information for all kind of people. Keep that in mind. I'm not focused on the one kind of audience. I'm focused on all the audience. They're trying to learn the technology, IT, build a great computers, build a great system, build a great PCs, all those audience. So alright guys, that's pretty much it. I showed you the AIDA64, everything what you need to know about the AIDA64. Let me zoom out, let me close the Corona, and now we're gonna go through the CPU benches. Let's start with the R15. This is the single core performance. I'm not going to show you single core performance, but I'm going to show you multi-core performance in real time. Keep in mind that I'm recording this video today with NVIDIA ShadowPlay technology. It's a software that recorded on the same system, so it's utilizing the system performance. So that means that pretty much it's going to utilize my video card, but video card is not used throughout this benchmarks that I'm going to show you in real time real quick. So pretty much you're gonna see that results will be the same, and the results that you're gonna see right now is just results without the recording. Okay, so keep that in mind. And now I'm gonna show you with the recording with NVIDIA ShadowPlay, in case if you would like to test it and share your results so we can compare it. Okay, based on those type of rules. Hopefully guys this makes sense. So as you can see, 223 points single thread performance, and multi-thread performance 1167. I also tested the OpenGL, which is 245 FPS for Titan RTX video card by NVIDIA. It's going to be Turing GPU architecture by NVIDIA. So alright guys, let me go ahead and do the I'm going to do the multi-core benchmark, but before I'm going to do that, I'm going to go ahead and execute it. I'm going to execute the CPU ID application. So we're going to run this application. I'm going to show you the temperature and how we're going to drop the frequency. So you want to keep your eye at this application right here, and you want to keep your eye at the frequencies right here, the current and the temperature, and you're going to see how it's going to drop, because we're going to thermal throttle. It's going to pretty much get so hot, and the Corsair H150i Pro water cooler AAO, one of the best water coolers, cannot hit it. Pretty much this is how fast it is, and this is how hot it is. So it's going to thermal throttle the frequencies, and just to reach a normal frequencies and normal temperatures of the operations that is accepted by the Intel driver. Hopefully guys this makes sense. So multi-thread performance, so check it out. It's going to be fast, but not so fast because I'm only using 6 core. So keep in mind, if you're using the 9900K or Intel 9000 series CPUs, of course, if you're using it as workstation, of course you want to have those cores enabled. So you want to use all the 8 physical cores and hyper-threading technology to get the best gains out of the CPU, because it's going to be faster than as workstation than this 6 core even running at 5.3 GHz, because the hyper-threading technology also going to help a lot for 9000 series Intel CPUs. Hopefully guys this makes sense. It brings about 3 additional cores, and those 3 additional cores through the 8 virtual cores, which is equal 3 physical cores, is a big deal. Hopefully guys this makes sense. So 1129, this is the score, and you saw that we reached the 100 Celsius at some point, and you saw the frequencies was dropping, and you saw the maximum wattage was not even 125 watts. So Intel keeps that values and is dropping the frequencies, and it's learned that type of activities from the Xeon's E5 CPUs and E3 CPUs, from their enterprise CPUs technologies. All right, so we did this, and yeah, so right here is my dual Xeon E5 2699 V3 CPU. This is how fast it is on a Chinese motherboard, and believe me or not, this is so fast. This is unbelievable fast, and pretty much it's 3 times faster, even more than that, than this 6 core 6 threads, even running at 5.3 GHz. But as again, we're talking the workstation, we're talking this as benchmark as pretty much rendering. So when you're using the Cinebench 4D application 3D render application for 3D architects and 3D artists when you're creating some scenes in 3D art, 3D models. And when you're rendering, when all the CPU cores utilize, you're going to pretty much need as more cores as possible. But as again, for those who is curious, and for our curiosity, we decided to go ahead and bench i9-9900K as PC gaming tune, and bench it as workstation to find out. Hopefully guys this makes sense. So it's 5 times, above 5 times for 6 physical cores. This is pretty good. Okay, but running 5.3 GHz, and the score is pretty good as well, but not far away from 9900K. Let me zoom in for you. And 9900K is pretty much Intel 3000 series CPU generation, which is the what 6th generation older than this current generation of this video. So, and look at this, not far away, oh my god, it's like 1000, it's just 100 points more, not even 1000 points more. But when we are talking 12,900K, the values will be doubled, and this is even more than doubled. And this is, guys, why you want to buy yourself 12,000 series Intel CPUs. They are amazing, and if you can afford, go ahead and grab yourself 12,900K CPU from Micro Center. If you live in the United States, Micro Center is amazing. Grab it and enjoy it. All right. So that's it. We've done this benchmark, explain all the values, everything what you need to know, and you saw what's going on. Let me go ahead and close this. We're gonna reopen this just in case. Let's start with the R20, the next, the newer benchmark for the newer versions of the Cinebench or the newer versions of the Cinema 4D application for the 3D artist. And I'm using the Cinema 4D application. It's just amazing application, just like 3ds Max, guys. This is exactly when you need the cores, and this is exactly when I'm utilizing the cores out of my 2 Xeons E5 2699 V3 processors. Okay, so we're gonna reopen this monitoring tool. Okay, here we go. We got the monitoring tool just to keep an eye, so it's refreshed for us to see what's going on. And R20, and I'm going to show you the single thread values 515. We are pretty much outperforming anybody, except as you can see, this test doesn't have 12,900K values, but I'm going to include for you the values, of course, on the screen. But as again, I'm just going to add to this video, just include the values of the modern CPUs. So we're going to compare this value with the modern CPUs. But I'm not going to add to this video, as again, I'm coming in real time. So don't forget, guys, to smash that like button. It's just one take for you. A lot of time, money, energy is invested, but a lot of value is provided to you. So hopefully this value will be very valuable to you. Instead of building i9-9900K, get yourself i5 12,600K. This CPU will be much better than i9-9900K. Believe me, guys. All right. So 515 points. As you can see, the multi-thread ratio is way above 12x, just like we were under the R20. This is almost 5.5 times, which is great. So the newer version of the Cinema 4D applications for the 3D artists, 3D architects, the newer release will be faster for the newer CPUs, because it's going to utilize the newer Intel CPUs or AMD CPUs features. Hopefully, guys, this makes sense. So that's why the newer CPUs will be always taking the lead. So if the margin in price just a little bit, go ahead and buy the newer CPU. But if the margin price is big and you can compensate it with the dual CPU or something like that and be like above 3 times faster, go ahead and build yourself dual Xeon E5 2699 V3. But keep in mind that 12,900K CPU will be faster, a hair faster than 2 Xeons E5 2699 V3 CPUs, and this is unfortunate, but it is what it is. More information about it is coming over the UHDking.com that you don't want to miss. It's going to be a great video for you to watch. But this is the score, 515 points, single thread performance. All right, so multi-thread performance is 2825 points, and I'm going to go ahead and demonstrate it for you about right now. I'm going to go ahead and click run, We're gonna open up the application, and we're gonna see, pay our attention to our frequencies utilization right here at the left bottom corner, to the temperatures when the CPU will reach the thermal throttling, about 30 seconds, and even with the Corsair H150i Pro cannot cool it down. Guys, keep an eye over my YouTube channel, uhdking.com, and I'm going to pretty much post the links for the NMAX 360mm water cooler AAO that you don't want to miss for the price of $79, sometimes even $69. Do not miss it, buy it, because the performance out of that cooler similar to the Corsair H150i Pro, but Corsair H150i Pro costs $149 versus the $79, so it's cost double, and for the similar performance, maybe 2 Celsius cooler, but that's a deal that you don't want to miss. Believe me, guys, especially if you're PC builder, PC hardware enthusiast, if you're building computers, if you're building PCs, this is pretty much the deal that you don't want to miss, and pretty much the information provided over the UHD King will be a golden information for you. So do not miss, and subscribe to my YouTube channel. Do not miss any single video. Support me with your likes, visit my sponsors, and more great videos are coming. As you can see, I'm sharing a lot of great experience. There is no copycats over here allowed. Everything what I'm sharing is a great experience, great information, great data, dedicated pretty much to improvements of your own experience. Hopefully, guys, this makes sense. So we're almost done here. It was quick. 6 cores at 5.3 GHz is quick, but nothing like 12,000 series, even Intel i5. Intel i5 12,000 series will destroy i9 9900K. Completely destroy this 6 core 5.3 GHz as multi-thread benchmark, as workstation. But when we are talking gaming rig, there's a video coming over the uhdking.com that you don't want to miss, guys. All right, so we scored almost the same score as you can see right here, 2,716 points. So just because I was recording this video in real time, keep that in mind, I'm speaking in mic in real time, and we are playing the music in real time that you saw. By the way, the music to this video is commercial free. I mean, not commercial free, but I have the commercial license, so it's all right reserved, so free out of any royalties, so you cannot claim any commercial royalty for this video audio track. Keep that in mind. And the audio track will be Unrest by ELPHNT, provided by YouTube. Thanks so much to YouTube for that. Alright, so let me go ahead and close that, so we test that, and now we're going to move to the latest benchmark, which is where Intel 12,000 series CPUs will shine, especially 12,900K, because 12,900K Intel CPU is outperforming my 2 Xeons E5 2699 by a healthy 30%. It's outperforming 2 Xeons E5 2699 V3 processors with the 72 logical cores when hyper-threading technology is enabled, or the 36 physical cores are enabled. The Haswell EP technology, EX, Extreme Technology, EP, dual processors. It's outperforming the single Intel CPU 12,900K over here by 35%. That's why the Intel 12,900K CPU is the golden, guys, and this is the CPU that I'm gonna get, and this is the CPU that I'm going to review over the UHD King, and you don't want to miss. You want to thumbs up. And let's go back to this CPU, because most likely you're building a system, most likely you got the deal, and this is exactly why you want to build this. When you're gonna get this CPU for $160, this is going to be a deal, and most likely you're watching this video before buying the CPU for $160-180. Above that, get yourself i5 12,000 series CPU, guys. Okay, and I aim at 12,600K with a great motherboard around $150 that has the overclocking capabilities, and most likely you're watching this video in 2023. You can get it used on eBay at the great price. Hopefully guys this makes sense. So as again, my videos are multi-angle guys, not as fast as possible, but providing a lot of values for future PC builders. Let's say you're just a beginner, you're watching my video and you're going to learn a lot by just watching my video before you're going to make that next step by building your own computer, by becoming the IT professional, by becoming the technologist. And if this is your hobby, this is a great hobby. This is much better hobby than gaming. This is a much better hobby than anything, but you want to make sure that you're not going to be focused too much on this hobby, that you're going to learn and you're going to move on to the highest IT level. So hopefully guys this makes sense. So as again scored just like guys at the single thread performance, 1345 points right here. Let me zoom in for you. This is for the single thread performance. This is a great value, but check it out. Intel mobile CPU, Core i7 1165G7. This is the mobile CPU, 15 watt. When it's running 15 watt, that CPU can run like a mobile version and run on the AC version, which is 28 watt. When it's running mobile version, it's outperforming our 6 core 6 thread, 6 physical core, 6 thread running 5.3 GHz our CPU, which is crazy fast, and that mobile CPU is outperforming our CPU. That's how crazy anything Intel above 11,000 series or 1165, even G7 mobile CPU is going to be crazy. But keep in mind, when we're talking laptops, Intel notebooks, do not even consider that. Consider Apple MacBooks based on M1 chip. This is going to be a win-win for you because they're going to last you 7-10 years, because Apple deception went away when Apple switched from Intel to their own mobile CPUs. It's going to be guys great as just like iPad, iPhones, believe me. Alright, so we saw that, and then multi-thread was 7042 points right here. Keep in mind that my 2 Xeons E5 2699 V3 is scoring above 21,000 points, so it's almost 22,000 points. It's like 21,900 something points, so it's 3 times faster than this 6 core 6 threads operating at 5.3 gigahertz. Okay, and price value will be almost the same. 2 Xeons E5 2699 V3 costs about $170 right now, used like new in the beginning of 2022, so it's going to be like $340. This is exactly how much you can get used i9 9900K. So as workstation, of course, and this is workstation benchmark, the Xeons will be the best, but we benchmark, we find out how this i6 9900K, which is pretty much i9 9900K converted as i6 with 2 cores turned on for the, as again, gaming tune, but how it performs as workstation. And keep in mind guys that I'm going to show you the how it performs at stock as well, so we're going to have a lot of information to compare over the UHDking.com. okay, as again on the background, this is the system, how it's looking right now. So my system RAM is cool with this big 200mm cooler master fan and Corsair H150i Pro and Titan RTX, an ASUS motherboard, beautiful Z390, ASUS Maximus Hero. So yeah guys, so you saw everything what you need to know. Let me show you the last pretty much the 7-zip and WinRAR. So this is WinRAR single thread performance. Let me zoom in. A screenshot without the recording, of course. So result is 2586 single thread performance for 5.3 gigahertz, and this is going to be multi-thread performance. Check it out. WinRAR. So 11,404 score. And this is going to be a single thread performance on a CPU Z. Okay, and the speed will be, the compressing will be the 7,313 points, and the compressing will be 105,096 kilobyte per second. Okay, and the compressing, wow, pretty much 105 megabytes per second, while compressing was 7,000 300 kilobytes per second. Okay, and total rating 99% because this is single thread performance, and 8,000 8,499 MIPS. Okay, CPU Z. So this is the archiving. This is multi-thread performance right here. As again, it was running 1 minute for CPU Z, and for the for 7-zip, and for the WinRAR benchmark was running 1 minute. And on average, as you can see, everything is provided on the screen for you. So look how we improve in terms of the value by adding additional 6 cores to the performance. So rating is 531%. So you're right, it's almost 5.3 times versus the single thread performance, pretty much scaling out of those 6 cores. It does the same thing as you can see under the 7-zip. It does the same thing under Cinebench. It does the same thing under CPU Z. So pretty much we got our eyes. So those 6 core performs like almost 5.5 cores in real life. Okay, the score will be 47,754 MIPS. Okay, that's it, guys. Let me close it down. Everything pretty much was explained to you. Hopefully you enjoyed that, and don't forget to smash that like button. A lot of time, money, energy was provided. I'm going to record an additional video when I'm going to review a stock performance out of the i9 9900K. It's going to be as additional video, and this is as bonus material. And then it's going to be an overclocking video when I'm going to show you how to overclock to 5.3 safely in home safe environment. So you don't want to miss that. Go ahead and smash that like button, as again a lot of time, money, energy is provided. Subscribe if you are not a subscriber yet. It's a great videos over the UHDking.com, such as building your own computers, repairing your computers, about the technology, software development, graphic design, 3D modeling, 3D animation, building a software, building application, building a web sites will be provided to you over the UHDking.com that you don't want to miss. And subscribe, guys, and I'm gonna go ahead and continue to my business. I will see you guys in the next videos, and yeah, share it with your friends and check out the videos that I'm putting for you on the screen. It's nice to know you, and have a great 2022. As you can see, today is February, and we just started February 2022, and hopefully the virus is going to go away and everybody is going to sound great, and we're going to get back to kind of normal activities. Okay, for some of the folks, but for some of the folks, their activities didn't change. But anyways, I'm hoping the best for you, and I will see you in my next videos.